Okay, so what we're doing is we're looking at some fraction manipulatives, and I have us lined up here with the 1 bar, and so that represents a whole. Could be a whole apple, a whole pie, a whole candy bar, could be lots of different things, okay? But if we cut it into small pieces, that's where fractions come from. So we have these little blue blocks that represent 1/8. Each block represents 1/8. So there are how many blocks that make up a whole?
1, 2, 3, 4, 5, 6, 7, 8, 8.
Okay, so that means 8/8 is the same as 1. So any number over itself is the same as 1. And you've probably studied that before. All right.
What about these in there?
Well, that's a good question. You want to know what happens when we put the 12s in?
There's going to be 12, 12.
That's right. And so what does that equal?
12 times 12.
12 over 12.
12 over 12.
Any number over itself, which is 12 over 12, equals. Okay, good. All right, so we're going to line up the 12s. They almost look like dominoes, don't they? And so that means which piece is bigger, the 1/12 or the 1/8?
The 1/8.
Okay.
No, the 1/12.
No, you were right the first time. The 1/8 piece is larger.
Like the squares larger? Okay.
So that means we have, if we were going to share this candy bar with 12 of our friends, they would have little bitty tiny pieces. But if we only had 8 friends, we would have bigger pieces.
If we had one friend, we could just
split it in half. That's right. So that's what this would look like. So I have put the 1/2s on my place over here.
This is when you half it with your
friends. Right. And so as the numbers get, like 2 is smaller than 8, right? So in
8?
fractions.
No, the 2's bigger than the 8.
Right. So the 1/2 piece is bigger. You're right. And so as the numbers get bigger, the piece gets smaller. Does that make sense?
Wait, the number gets bigger. Excuse me. Oh, yeah, you're right.
Okay. All right. So now what we're going to do is we're going to say somebody came by and wanted a piece of our candy bar, and so we gave them 3 pieces, 3 little bitty tiny pieces.
Why can't we give them 4 big pieces and be nice?
Well, yes, that's a good idea. 4 big pieces. You like to share, don't you? All right, so now, how many blue pieces do we have left?
We got 4 blue pieces, and take that out. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9, 4. We only have. I take that out because that's taken up. Okay. So do you add all that up and then you share?
Okay. So we have 1, 2, 3, 4. 4/8 or half of the candy bar, because this is the same thing as half. Okay, so 4/8 or half.
6 of these.
That's right.
So that means if we take 3 out, if we just gave him half of a candy bar.
That's right.
That means our candy bar is 1, 2, 3, 4 blocks big.
That's right.
Tall.
That's right.
So that means we can have a red candy bar. But what if he ran away and did something with it? Like, what if he burned our candy bar? What do we do about that?
If you burned your candy bar,
If he burned our candy bar.
well, burning a candy bar is not the thing to do. The thing to do is eat it before somebody else gets it, right? Unless you're going to put it in the microwave and melt it and pour it over some ice cream. That's making me hungry. Okay, so we're going to do something else now. I just want you to keep your 12s out. Okay, so now if I have 3 12s and you have 4 12s, how many do we have? Okay.
7 12s.
Okay, good. So now I am going to eat 2 pieces of this pie. And how many do I have left?
5 12s.
Okay.
Pieces.
All right. So what we did was we added the top numbers and then the bottom number stayed the same, right? So if we had 3 12s plus 4 12s.
1, 2, 3, 4, 5, 6, 7,
7 12.
Yeah, that's 7 12.
So we add across the top and the denominator stays the same. Do you remember what the top number is called?
The numerator.
The numerator, good. Okay, so okay. So now if I said, how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, and
7, 8, 9.
So I have 8 there, and I want to put 3 back with it. So it would be 8 plus 3.
I don't have another piece.
1, 2, 4, 6.
Yeah, I need one more piece.
Oh, you do?
Oh,
maybe I have too many. Yep. Oh.
Let me see this.
Here, see, it didn't line exactly up. Yep.
Okay.
Okay. So, you think you could work some problems like that?
Like what?
Where you added these fractions?
You need like this one. You get one of these pieces to make a 112. You need a 3 by 5. Make one of these. You need 3. No, that's I think too big. Yeah, that's too big. Dante asked you. Yep, you need 3 by 3 ones, and what is it called? To make a hole. 2 rows. Jacoby Fleming. How much is this? I know how much this is.
Well, how much?
It's half of this, cause look. Right there. Can you put that right there? See?
Alright, so here's what I want you to do. I want you to show me these problems with the manipulatives and then write the answers down.
But there's only
the boys, Jace, Malaysia, Diego, Adriana, Isaiah, boy. We need all the boys.
Okay.
I need Rachel Cash.
So can you do one before you go so I can make sure you got it?
Okay.
Do this one with the 12s
DJ Robert.
since they're already out here.
12K. That's 12. 1, 2. It's 8 12s.
Okay.
Nadia Adams. Nadia Adams.
Okay. Thank you, sir.
Welcome.